In this video, we're going to talk about how to solve radical equations. And so there's a couple of basic steps that we're going to follow first, or go through. First of all, your number one thing that you want to do is isolate your radicals. And sometimes this takes a couple of different steps, like you do it and then you have to do it again, but that's what you're trying to do. And so you're going to do that, various steps we'll go through, and then you're going to get rid of the radical using inverse operations. So if you've got a square root of something, then the inverse operation is to square it. If you still have a radical after that, then you're going to repeat, and that's what I'm saying, that you might have to go back and do it again. Solve whatever equation is left, and then this is really important in radical equations because it's possible to have non-real answers, and so you have to check your answers. If you have answers or solutions that do not satisfy the equation with a real number, then you're going to call it an extraneous solution, and so we'll see some examples of that. So we'll start with this radical equation. The square root of 2x plus 5 is equal to 7. So I can see that my radical is this right here. That's the radical part. And by definition, a radical equation is when you have your variable underneath a radical symbol. So that's how I know that it's a radical equation. The radical is isolated. There's nothing I can do more. You cannot take away the 5 because it's under a radical. And so this is just treated as a single number. And so that's what I'm going to look at it as. So to get the radical out of there, I am going to do the inverse operation, which is to square that. And so what you do to one side, you have to do to the other side. So the square root of 2x plus 5 squared is 2x plus 5, and 7 squared is 49. Now it's just a simple two-step equation, and you're going to get x is equal to 22. Now you have to check, and so we're going to put this back in there. So we're going to have the square root of 2 times 22 plus 5, so that's the square root of 49, which is equal to 7, and so it checks. So my solution is 22. Okay, next example. We notice we've got the radical right here, but there's something still on that side, and that's what we're going to need to get rid of before we can do anything else. So we're going to first get rid of the 13 by subtracting it. We can do that because it's not inside the radical. So what we're left with is the square root of 1 plus 2a is equal to 8 minus 13 is negative 5. Okay, now we can square both sides to get rid of our radical. And so the square root of 1 plus 2a squared is 1 plus 2a. And negative 5 squared, since there's parentheses around that, we're squaring the whole thing, it's going to be 25. So now I'm going to subtract 1 from both sides, and I get 2a is equal to 24, and so a is equal to 12. Okay, that's my answer, but we have to make sure we check it. This is not just recommended, you have to do this in these types of equations. So we're going to do the square root of 1 plus 2 times 12, and that's the square root of 25. The square root of 25 is 5, and then I'm going to do 5 plus 13 equals 8. Well, obviously that is not true. So what happens is we now have what we call an extraneous solution because it doesn't actually work, and so we will just say that there is no solution. Okay, next equation. This one is written in rational exponent form, and so remember that this right here, that's actually a radical, so I've got the square root of 3x plus 1 to the third power. That's another way to write that. We're not going to need to write it like that, though, if you just recognize that this is an isolated radical. So what I can do is I can just raise this to a power that will get rid of this radical piece. So if I raise it to the second power, that will do it, but then I still have kind of a mess on the left-hand side. So what I could do is I could raise it to the 2/3 power, because according to my rules for exponents, what I would do then is I would have to multiply my radical or my exponents, and so actually that's going to work out really well because I'm going to have 3x plus 1, and then 3 halves times 2/3 is just 1, so this is all I've got, and so that makes that side nice. And then what you do to one side, you have to do to the other side, so 64 to the 2/3 power. So remember how that works. That means I'm going to do the cube root of 64 squared, and I don't actually have to do too much with that. 64 is 4 to the third power, and so if I have two of those, 64 squared, that's what I've got. So I'm going to take out 4s and 4s, and I'm left with 16. Okay, so then just a two-step equation, subtract 1 from each side, and you get x is equal to 5. So before we call it quits, we need to make sure and go back and check it. So we've got 3 times 5, actually I'll just write 15, plus 1, okay, that's 16. Okay, 16 to the 3/2 power. We can look at that as, write that as 16 to the 1/2 power to the 3rd power, because 16 to the 1/2 power is 4, to the 3rd power, that's 64. That's what it needs to be, so this does work, and my solution then is 5. Okay, next equation. Again, we've got that rational exponent, so if I just raise that to the 2/3 power, and so I'll raise the other side to the 2/3 power as well. If you want to pause this video and see if you can get the right answer, then you can come back and see if you did it right. Okay, 27 to the 2/3 power, I'm going to look at that as 27 to the 1/3 power to the 2nd power, because according to my rules of exponents, I would just multiply those and I get the same thing. So 27 to the 1/3 power is 3, and 3 squared is 9. So x is equal to 9/4. Okay, let's check that. So I'm going to have 4 times 9/4 to the 3/2 power. So 4 times 9/4 is 9. I'm going to take the square root of that, and then I'm going to cube it. So the square root of 9 is 3, and cube it is 27, and that's what it is supposed to be, so I can say that my answer is 9/4. Okay, this next equation is different because you'll notice we have radicals on both sides of our equation. Really not too much of a big deal in something like this because we can just square both sides, and that will eliminate both of our radicals for us at once, and so it actually becomes a pretty straightforward equation. And so I'm going to move all my variables to be on one side. So I'll have 1 is equal to 2x minus 4. Add 4 to both sides. So x is equal to 5/2. Okay, we need to check that. So I'll have the square root of 2 times 5/2 is 5, plus 1, so that's the square root of 6. On the other side, seeing if that's equal, I'm going to have the square root of 4 times 5/2, that will be 20/2 or 10, minus 4, and so that's equal to the square root of 6, which is equal, and so that works. So my solution is 5/2. Okay, with this next one, the thing that's different about this one is that this minus 1 is outside of our radical. If I was to add it to the other side, it's still outside that radical, so there's nothing I can really do about that. So the only thing to do is go ahead and square both sides, because I've isolated the radicals as much as I can. There's nothing else I can do, so I'm going to square both sides. With a problem like this, this is where you have to be really careful about the rules that you already know. So if I'm squaring this, you need to make sure that you remember that this is what it means. So on the left-hand side of your equation, you're going to do square root of x times square root of x, square root of x times negative 1, negative 1 times the square root of x, and negative 1 times negative 1. And that simplifies to x minus 2 square root x plus 1. Okay, on the other side of the equation, that one's simpler, and it's just 2x plus 1. Okay, I'm going to get all my variables together, except the thing is I can't really do anything with that as far as combining like terms, so actually I'm going to go back to the rule number 1 about isolate our radical. So what I'm going to do is I'm just going to get everything else on the other side. So I have negative 2 square root x equals x, and then that's gone. So now I'm back to the rule where I'm going to square both sides. I could divide both sides by negative 2, but that doesn't really matter if I do it now or later, so I'm just going to do that. Negative 2 times negative 2 is 4. Square root x times square root of x is x. On the other side I have x squared. Okay, so you might recognize this now as a quadratic equation. And so I need to treat this as quadratic equations, and how do I know how to solve that? So what we've learned is that if you get 0 on this side by moving the 4x, I can solve this by factoring. And so I notice that I have a GCF of x, and then using the zero product property, either x equals 0 or x minus 4 equals 0, which would mean x is equal to 4. So I actually have two solutions here. So that means I need to try each one of them individually. So I'll first try 0. And so that's going to be square root 0 minus 1. That's 0 minus 1 equals, and the square root of 2 times 0, which is 0 plus 1. So I've got square root of 1 over here. The square root of 1 is just 1. It's not negative 1. We're just talking about the principal square root. So that actually becomes an extraneous solution. So that is not our solution. Now we have to check 4. Does 4 work? So I'm going to try that in both positions. So square root of 4 minus 1, that's 2 minus 1, which is 1. Is that equal to the square root of 2 times 4, which is 8, plus 1? So the square root of 9, which is 3, is obviously not equal to 1. And so that's also an extraneous solution. So even though we started out having two solutions, we find out that neither one of them actually works. So we're going to end this problem with no solution. Okay, you should now be ready to do your practice. If you need any questions, or if you have any questions, see your teacher.